Okay, ticker tapes are useful for describing the motion of an object. If the dots are equally spaced, then we know that the displacement is changing by the same amount for that time interval, so the object's moving at constant velocity. If the dots increase the distances for every time interval, then the object is accelerating. So one of the first things we need to do when we do these calculations is to check the frequency at which the dots are being made. So in this case, the frequency is 10 hertz. So to convert the frequency into the time period, we say 1 over the frequency. 1 over 10 is 0.1 second. To determine the average velocity for a time interval, it's the change in displacement over the change in time. So the displacement for the section AB is 2 millimeters. We need to convert that into meters by dividing by 1,000. We then divide it by 0.1 seconds and we get 0.02 meters per second. Velocity is a vector. If you look above the tape, there's an arrow to the left, so it's showing you the direction the tape's moving. So the velocity, average velocity between A and B is 0.02 meters per second. We can also work out the average velocity between a bigger time interval. So the second one I've done is between section B and D. Then you need to add the total displacement between B and D. So it's 4 plus 8 millimeters is 12 millimeters, divided by 1,000. B to C is 0.1 and C to D is 0.1, so you've got to have the total time interval, and we get 0.06 meters per second left. Now we have two average velocities. In order to calculate the acceleration, you need to know the instantaneous velocity at 2 points, because acceleration is the final velocity minus the initial velocity divided by time. So to calculate the instantaneous velocity at a given point, it's equal to the average velocity in the middle of that time interval. So for example, the average velocity between A and B is the instantaneous velocity at the midpoint of that time interval, which is 0.05 seconds. The average velocity between B and D is the instantaneous velocity at the midpoint of that time interval. Therefore, that's the instantaneous velocity at point C. Therefore, the time interval at point C is 0.2 seconds. Okay, now that we have those two instantaneous velocities, we can take the final velocity minus the initial divided by those two time intervals. And then we get the average acceleration as 0.27 meters per second to the left because it's a vector. Sometimes we want to show whether the acceleration is constant or not. So the definition of acceleration is the rate of change of velocity. So if the velocity changes by the same amount, then we know that the acceleration is constant. So we had the average velocity between A and B. I've then calculated the average velocity between B and C as 0.04 meters per second. I take the difference between those two and I get the difference in velocity is 0.02. The average velocity between C and D is 0.08. If I take the difference, I get 0.04. So I can see that the change in velocity is not constant, therefore the acceleration isn't constant. In this example, it's not constant, but if you look at the examples in your notes, that does show you constant acceleration, which is what you would normally get. This one just happened to work out as not constant velocity.